Hey guys, in this week's video we're going to talk about yet another update on the CNC router MACH3 screen sets. I've been developing custom screens for all types of CNC routers. They come in all of shapes and sizes, configurations. A lot of individuals now are using these CNC routers not only to machine sheet goods but also aluminum, brass, all different materials, using fixtures, vices. So I wanted to try to make the screen and MACH3 versatile so that you could use it in any type machine configuration. Here recently I've been working on a custom screen set for a gentleman who wanted to be able to detect whether or not his tool had broken in the previous machining operation. In doing so, I realized that having the touch off tied to the G54Z0 was not an efficient way to check for tool heights. So I've went back and I've revamped and updated all the touch off routines to now use G53 machine coordinates. Your G53Z0 will never change as long as you don't mess with your home sensor. So having that as the reference point is the best way to go. So I've updated all the screens. I've added some new features. So let's take a look at some of that. On our setup screen, no longer do we have our touch off feed rate. We will now be using our search speed and our slow speed for the fine touch. We have now changed the way our touch sensor height is established. We need to insert a tool that has a known length. If you do not have a known tool length for the specific tool you're using, at the end of this video I will manually demonstrate a couple of ways that we can establish the tool length if we can't measure it because of the tapered tooling. Once we've established our tool length, we're going to insert that tool in the spindle. We're going to define our touch off location by jogging over the touch sensor and pressing set. Our maximum Z travel, we need to enter this number in here or jog down so that our shortest tool is below our touch sensor and press set. We're going to establish our tool change locations here. This happens to be a Y rack screen set, so we're going to have our rack placement on the Y axis. We're going to jog so that the tool is in the rack, and we're going to press set for each location. Very straightforward and simple way to set up your tool rack. We're going to set up our rack center line, our rack load height. This is for pick and place and or slide in tool holders. Our rack clearance, this is a position in front of the rack that our spindle will clear all of the tool holders and the rack. Our safe Z height, this is the height just below our home sensor so that we can clear any obstacles as we're traversing across our work envelope. Tool change feed rate, our delay. This is the amount of time it takes for our spindle to release and clamp the tool. And our clearance plane, this is the height in which an empty spindle can go across our rack here. So we want to jog to that position and press set. If we have a magnetic dust shoe, you can set the position here for X and Y and Z to go and pick up and retrieve this dust shoe and drop it off. Now this dust shoe motion works just like the same motion for tools sliding in and out of your tool holders. In the top left corner here we have our low air. We can enable this. If you connect a inline air pressure sensor, this will let you know whether the air pressure is sufficient to do a tool change. If not, it will prompt you and halt the tool change. If you happen to have a spindle that has sensors to let you know that the tool is clamped or unclamped, we can enable that here. Our tool touch off, after a tool change we want to check the tool height and get an accurate measurement. We can enable that. Our dust shoe here, we can park that and retrieve that if we have this enabled. And then last is rack extension. So if you have a smaller CNC router and you don't have room in your work envelope to mount a rack and you want to have it pneumatically slide in and out of the work envelope, we can enable that here. Now once we have all of those parameters entered, we can go over here to our touch sensor height. We're going to press this button. It's going to prompt us. We're going to get this message that says initializing touch sensor height check. Would you like to establish the touch sensor height? We're going to select yes. We're going to first move to safe Z. I have it set somewhere around in here. And then we're going to reference the Z axis. We're going to then position the touch sensor. We're going to jog down at the probe feed rate. This is on the probing tab, the search speed. I have mine at 25 inches per minute and my slow speed at 10 inches per minute. But we're going to jog down to find the initial touch sensor location. We're going to raise up, slow speed, and then we're going to go back to where we started, and we've established our touch sensor offset. So now that we have our touch sensor height established, we're going to go to our ATC tab. We're going to do some tool changes. So we have our brake enable check. What we're going to do is we're going to enable that. We're going to set our tolerance. Now for this demonstration, I'm going to set the tolerance to thousandths of an inch. Over here you can see we have our extend and retract. This is to extend and retract the rack. We have our tool data here. We have our setup tab, our air pressure. When the air pressure is good, we'll get a green LED. Delete, this is to delete all the tool information. So let's go ahead and do a tool change. We're going to go from tool 8 to 6. These are the two tools that I have actually loaded into the rack here. Okay, next we're going to just do a tool change and demonstrate that. So currently I have tool 6 in the spindle, and I'm going to get tool 8. We have our tool brake enable active. That's here on the ATC tab. Beside that is the tolerance DRO. We currently have this set for a thousandths of an inch. Tool length that's stored in the tool table and the tool length measured is more than a thousandths of an inch. It will pop up an error message. So let's do a tool change. So we're going to change from tool 6, which is currently in the spindle, to tool 8. So I'm going to press 2 because I have tool 8 loaded in the slot 2 here. So I don't know if you noticed, but you could hear the output for the solenoid to extend the rack, which is the first thing we're going to do. Now we're touching off, measuring tool number 6, which is the tool that was currently in the spindle. The tool length was within tolerance, so now we're going to store tool 6 in slot position 1. Release the tool, go to our clearance height, open the spindle back up, grab tool 8, going to safe Z. Now we're going to go touch off this tool and measure it, and then begin our next operation. We've deactivated the solenoid to retract our rack, and now we're machining the next operation. If for some reason after this machining operation something happens and the tool breaks and it does not fall within the tolerance that we put in here, then it's going to prompt you after it checks. So I've entered in here 0 as my tolerance so that it will initialize the pop-up. So we're going to do press 1 here to change to tool number 6. Again, we've extended our rack. We're going over and we're going to touch off tool number 8 and compare it to the information in the tool table. It stops and gives us a pop-up message and says tool breakage detected or out of tolerance. Do you wish to continue with the tool change? Now you have two options here. You can continue with the tool change if the next machining operation is not going to be influenced by the previous one, you can continue on, or you can select no, which will return the spindle back to where the tool change was initiated and move the Z-axis to safe Z. That way you can check the tool, inspect it, change it if necessary, and go back and rerun your operation. We're also going to deactivate the output 5 for the rack so that it will retract, and we're also going to program stop to stop the program where it was. So we're going to select no. Notice that you see the LED on the ATC tab turns red to let you know the tool break has occurred. So we've retracted the rack and we've moved back to where the tool change was initiated. Now we can inspect this and make any corrections. The program has stopped and we can restart it from where we stopped. Alright guys, well that wraps up this video. I think adding the tool breakage feature to the CNC router screen set is going to be beneficial to a lot of you. Likewise, and more importantly, the changes in the touch-off routines I think will benefit everyone. It's a lot simpler. No longer is the touch-off tied to the work coordinate Z0, and that just makes it a lot simpler for everybody. It doesn't matter now where you set your Z0, what fixture you're using, the touch-off will be in machine coordinates. Guys, thanks for watching my video. If you're new to my channel and you're just tuning in, click on that subscribe button down below. When I post a new video, they'll send a link. If it's something you're interested in, you can stop by and check it out. Thumbs up if you like the video, and most importantly, be safe.